Hello and welcome back to another episode of Math with Son. Today we're going to be doing a problem and it's going to take a free body diagram but expand it further into Newton's second and third law, but using it in the most appropriate AP way possible, which is not giving you any details, but you have to understand and be able to manipulate formulas throughout. Okay? So, with that in mind, the first time we're going to do this twice. The first time we're going to go through this is we're going to be going through it with numbers. We're going to create some numbers to make it make sense. So two blocks are being pushed across a surface with an external force F. Great. That's the human. As shown on the figure on the right. The mass M2 of block 2 is greater than the mass of M1 on block 1. The blocks begin at rest, so they were not moving before. The surface is also smooth enough that friction forces between the surface and the blocks and everything else is neglected. It's negligible. Okay, so that would have to be stated, or you would have to assume that friction doesn't exist. All right, we at first are expected to derive an expression for the acceleration of block 2 in terms of block 1 and 2 and friction. So before we do this, we need to first realize this is a very difficult problem to just do without first starting to plug in some numbers. So let's say that the mass of 1 is equal to, let's say it is equal to, it's smaller, let's say it is equal to 4 kilograms. And let's say that the mass of 2 is equal to 8 kilograms. We'll make it double. And let's say that the force that this dude over here is pushing on it is 24 newtons, okay? Because force is equal to mass times acceleration, this will all be very helpful. To derive an expression for the acceleration of block 2 in terms of M1 and M2 and all that stuff, we need to first figure out what is the overall force of the system because they're moving in tandem. So they are only going to be accelerating together. 1 is pushing 2, which means they're accelerating at the exact same speed. Well, the force exerted over the overall system is 24 newtons. That would mean that 24 newtons would equal mass, which would have to be combined. 4 plus 8 would be 12 kilograms times acceleration. What do we have to do to figure out the acceleration? We would have to divide. And if we divide, we'd find out that our acceleration in this case would be 2 meters per second squared, because 24 divided by 12 is 2. Okay, well that tells us something. That tells us that we needed to combine the mass of 1 and mass of 2 to be able to get the 12. And then we needed to divide to get our acceleration. So with that in mind, let's do the problem without that. All right, derive an expression for the acceleration of block 2 in terms of block 1 and block all of the other stuff. So we have the Newton force, we don't know what it is equal to, we made it up last time, we would have to add the mass of 1 and the mass of 2. Both of those are in terms of kilograms. And we would have to multiply that by acceleration, okay, which is in terms of meters per second squared. Well, we would add them, we got that part. We would need to divide, and we would end up getting our newtons divided by acceleration is equal to the mass of 1 plus the mass of 2. But that would be what we would do if we were solving for the masses. Whoops. What are we doing if we're trying to solve for acceleration? Scratch that. We would have to divide by mass 1 and mass 2. Well, that would be newtons divided by m1 plus m2 would equal acceleration. And newtons are, in terms of what they actually are, they are in units kilograms times meters per second squared. Well, if we divided m1 and m2, which would be the mass 1 plus mass 2, we could kind of factor out a kg. That would cancel and give us an acceleration, which is meters per second squared. Okay? So it also kind of makes sense that it would be like that. All right. Part B. How does the acceleration of block 1 compare to the acceleration of block 2? We've already answered this. They are moving together in tandem, so their accelerations are going to be the same. All right, so part B is done. Let's see, derive an expression for the force of block 1 on block 2. Well, let's go back to our numbers so this will be a little bit easier. So block 1 is 4 kilograms. Block 1 is 4 kilograms. And block 1 is moving at 2 meters per second squared because they are both moving at 2 meters per second squared when we did this first example where we plugged in random numbers. Well, if block 1 is 4 kilograms and it's moving at 2 meters per second squared, the force of block 1 would be mass, 4 kilograms, times acceleration, 2 meters per second squared, which means the force is going to be 8 kilograms per meters second squared, which means that we have a force of 8 newtons. Okay, well that is the force of block 1, and therefore that is the force that block 1 is acting on block 2. So part C would be 8 newtons if and only if we had numbers. Okay, so we don't have numbers. We don't have numbers. So what did we do? We took the mass of block 1 and multiplied it by the acceleration that we found out, right? So the mass of block 1 we would be calling M1. So M1, 1, not dot, times the acceleration formula. What did we figure out the acceleration was last time? Well, we figured out the acceleration was newtons divided by M1 plus M2. So if we do that, M1 times newtons divided by M1 plus M2, what would happen? Well, this is the same thing as saying M1 times N divided by M1 plus M2. You cannot cancel out the M1s. Can't do it. Do not attempt to do it. That is not allowed mathematically. If there was a multiplication symbol here, you could. That's a plus symbol. You cannot do it. Okay, so that is the expression for the force that is exerted on block 1 to block 2. So that would be equal to the force of block 1 to block 2. Ran out of paper there. All right. Derive an expression for the force on block 2 on block 1. Well, according to Newton's third law, every action has an equal and opposite reaction. So if every action has an equal and opposite reaction, force of M1 will be the same as the force of M2. Which you might be thinking, well, wait a minute, they are different sizes. How can the force of M2 be the same as forces M1? Well, you're only able to push M1 so hard, and that push that you get on M1 will be exerted onto M2, and that would be pushing back the same exact force on M1. So they would both be having that same formula for that, okay? So none of that would change, and it would all remain the same there. And that is the end of this video as well. All right, so that is going to do it for this one. Until next time, everybody, stay positive, and I will see everybody later. Bye.